So in this particular case, what we've got is a hydrated sample of magnesium chloride, and its mass has been determined as 5.77 grams, right? So, and we've also been provided with the mass of the anhydrous sample of the magnesium chloride, which is found to be 2.17 grams. And we effectively need to work out, well, what's the value of X, right? And so I'm gonna have a go and look into what that might be, right? Okay, so first of all, what does X actually mean? Well, what X basically means is for every 1 mole of MgCl₂, how many moles of H2O are there going to be, right? And X is going to be an integer value, okay? So given that idea, we're really comparing amounts of substance, what do we actually need to do? Well, we would want to convert the data we've got into molar values so that we can go and compare those molar values. So I'm going to go ahead and do that process. So we're going to start off with the MgCl₂. So yep, so the number of moles N is equal to the mass divided by the molar mass Mr, right? And in the context of what we have here, I'm focusing on the moles for the MgCl₂. So what we're going to effectively need to use is the anhydrous mass that we have here, right? So the number of moles for MgCl₂ is going to be equal to, and then the anhydrous mass, so 2.17 divided by the molar mass, right? And in terms of figuring out, well, what is the molar mass in this context, I'd be referring to the periodic table to work that out, right? So MgCl₂, so it's effectively Mr of MgCl₂, right? And in this case, that's going to be 24.3. So that's the relative atomic mass for magnesium plus 35.5 multiplied by 2, right? And if you kind of go through the process of working it out, what you should find is you get 95.3, and the units are going to be grams per mole, right? Okay, so the other thing is, yeah, so if we use that value, so let's go ahead and, so 95.3, right? And if you work that out, what you should get is 0.0227770, and that is going to be in units of moles, so moles. So now that we've done that, what we can do is work out the number of moles for the H2O, right? So number of moles for H2O, right? And this is in terms of like, well, what's the number of moles of this H2O here? But we've not been explicitly given what the mass for that H2O is, right? But we can work that out. So if we do effectively 5.77 minus 2.17, right? So this is effectively mass of H2O, right? Because of course, if you've got the compound with the H2O in it, and if you get the anhydrous sample, what you effectively, it's just a sample without H2O, so the difference is going to be what is made up by the H2O, right? So So you get here, you get 3.6 grams, right? And at this stage, yeah, you can add that to the formula here. So number of moles for H2O is going to be mass divided by molar mass. So it's going to be 3.6 divided by what the molar mass is. And in this particular case, you're effectively going to have, so you got 1 and 16. So for H2O, MR for H2O, that's going to be 1 times 2, right, plus 16, right, and of course that's going to give you 18, and that's going to be in units of grams per mole, right? So we can use that here, right? And if you do work this out, you can kind of, based on the inspection, you can kind of probably figure out what that's actually going to be. But in any case, that's going to be 0.2, right? And that's going to be in units of moles, right? Now at this stage, we've worked out the moles for the MgCl₂, we've worked out the moles for the H2O, right? What we really need to do at this stage is set up a comparison between the two in terms of molar ratio. So effectively what I'm going to say is, well, the number of moles of, and I'm going to put MgCl₂ on the left hand side, just because as you can see here is on the left hand side, right? So number of moles of MgCl₂ compared to the number of moles of H2O, right? And in this case, the MgCl₂ case, you got 0.022770, and on the side you've got 0.2, right? And so in effect, what you have, our goal, right, you're going around, like, our goal is, we're trying to answer the question, well, for every 1 mole of MgCl₂, how many moles of H2O, right? So in order to kind of move towards that objective, what we really need to do is try and get this value to be 1, right? And it's a question of, well, how do we do that, right? And the most straightforward way to get this to 1 is by dividing it by itself, right? So I'm going to divide that by 0.022770, right? And because I've done that on this side, and because it is a ratio, what I've done on this side, I do need to do on the other side. So the 0.2, I'm also going to divide by 0.022770, right? So on this side, of course, this is going to give us 1, right? On the other side, we're going to have 8.7835, right? And as I mentioned, x is an integer value. So with the number we've got here, corresponding relating to the H2O, we're going to need to round it to the closest integer, right? And because we've got 8.78, we do need to round it up, and so that's going to round up to 9. So in effect, it's 1. It's in a ratio of what is approximately 9, right? And therefore, we're going to say, well, x is equal to 9, right? And if x is equal to 9, then of course the formula is going to be MgCl₂ dot and then 9 H2O, right? So above here, MgCl₂, we're going to have, let me use a different color, might stand out a bit better, but 9 H2O, yep. So yeah, that's how you'd kind of figure that out.